For decades, scientists believed that hydrogen was something humans had to make, an energy carrier requiring advanced technology, electricity, and water. Yet beneath our feet, the Earth has quietly been producing hydrogen for millions of years. Vast geological formations deep underground act like natural reactors, constantly generating the world's simplest and cleanest fuel. This isn't science fiction, it's science we're only just beginning to understand. And as global demand for low-carbon energy surges, that hidden process may represent one of the most valuable discoveries in modern history. Hydrogen has always been seen as the ultimate clean energy molecule, light, powerful, and emissions-free when burned or used in a fuel cell. But the challenge has been production. Nearly all hydrogen today comes from natural gas or coal, releasing enormous amounts of CO2. Green hydrogen, produced by splitting water with renewable electricity, offered a sustainable alternative, but it's still expensive and energy-intensive. Then, quietly, a new possibility began to surface. Deep in old geological surveys and unexplained well emissions, researchers found traces of natural hydrogen escaping from the Earth. It wasn't created by humans, it was created by nature itself. This discovery led to a new field of exploration, what scientists now call white hydrogen or natural hydrogen. Unlike green hydrogen, which relies on human-made processes, white hydrogen is generated spontaneously underground through reactions between water and rock. In certain formations, especially those rich in iron and magnesium minerals, water molecules react with these elements in a process called serpentinization. The iron steals oxygen from water, creating hydrogen gas and new rock minerals. It's the same reaction that helped shape the early Earth's atmosphere and oceans billions of years ago. And even today it continues, silently and continuously, in the planet's crust. In places like Mali, France, and Australia, scientists have drilled wells and found hydrogen bubbling to the surface naturally. These discoveries shattered assumptions about hydrogen scarcity and cost. In the Malian village of Burakebugu, a well drilled for water decades ago accidentally struck a hydrogen pocket. When scientists investigated, they found a continuous flow of nearly pure hydrogen gas, clean, odorless, and consistent over time. The village has since powered its microgrid with that hydrogen for years, proving that the phenomenon is not just theoretical, it's real and renewable. So, what's actually happening deep underground? Imagine layers of ultramafic rocks, ancient oceanic crust saturated with water over millions of years. Inside, microscopic reactions between minerals and water generate hydrogen gas. The gas migrates upward through cracks and faults, sometimes accumulating in underground pockets much like natural gas. These are the hydrogen reservoirs geologists are now hunting. What's remarkable is that these reactions can replenish themselves, making white hydrogen a potentially renewable geological resource. Unlike oil, which depletes, hydrogen production continues as long as the chemical reactions have access to water and reactive rock. Other processes contribute as well. In sedimentary basins, natural radioactivity splits water molecules trapped in rock pores, a process known as radiolysis. In volcanic zones, degassing from the mantle releases hydrogen mixed with other gases. Even microbial activity in deep biospheres can play a role. The result is a planet that is, quite literally, generating its own supply of hydrogen, an energy source we've only just begun to tap into. This realization is reshaping how scientists think about the global hydrogen economy. Instead of relying solely on energy-intensive production, we might one day tap into natural sources the way we once tapped oil fields, only this time without the carbon. That's why major research programs are now underway around the world. In France, the government has launched initiatives to explore hydrogen-rich regions, after accidental discoveries in Lorraine revealed gas concentrations worth investigating. In Australia, geological surveys have confirmed large areas of hydrogen potential, leading to exploration permits that cover tens of thousands of square kilometers. In the United States, the Department of Energy has begun mapping natural hydrogen prospectivity, while private firms in the Midwest and Appalachia are already drilling exploratory wells. Early data suggests that white hydrogen could exist almost everywhere, beneath deserts, mountain ranges, and even continental margins. The challenge is learning how to find and capture it economically. Explorers use a mix of satellite mapping, magnetic surveys, and gas flux detectors to locate subtle surface emissions called hydrogen seeps. These seeps often occur alongside unusual geological features known as fairy circles, round, vegetation-free patches of soil caused by hydrogen oxidizing near the surface. From there, advanced modeling helps estimate how hydrogen migrates and where it might accumulate in larger quantities underground. If even a fraction of these reservoirs can be economically developed, the implications are massive. Natural hydrogen could dramatically reduce the cost and environmental impact of producing clean fuel. With no electrolyzers, no fossil feedstocks, and minimal power requirements, production costs could fall below $1 per kilogram, far cheaper than today's green hydrogen. Because the process originates from natural chemistry, it also produces little to no CO2, making it one of the cleanest forms of hydrogen on the planet. However, challenges remain. Extracting and storing hydrogen is not the same as extracting oil or gas. Hydrogen molecules are tiny and can escape through seals that would easily contain hydrocarbons. The gas must also be purified, compressed, and transported safely. Geological and environmental regulations designed for oil and gas may need to be updated for this new resource. And while the idea of renewable geology is compelling, it still requires years of study to confirm long-term sustainability and flow rates. That said, early pilots are already showing promise. In France, startups like Natural Hydrogen Energy and Eden Hydrogen are testing exploratory wells and planning pilot production. In the US, the Department of Energy has identified multiple regions with hydrogen potential, including parts of Nebraska and Kansas. In Australia, exploration companies are mapping subsurface hydrogen flows in the Northern Territory and Western Australia. Each new data point strengthens the case that natural hydrogen could be both abundant and accessible. From an investment perspective, this creates a whole new frontier. The race to unlock white hydrogen mirrors the early days of oil exploration, where small, agile teams may discover billion-dollar resources before the rest of the world catches on. Governments are beginning to take note. Some countries are offering exploration permits specifically for hydrogen, and investors are funding geochemical surveys to identify promising formations. The combination of science, sustainability, and economic potential makes white hydrogen one of the most intriguing stories in clean energy today. If we think of the Earth as a natural reactor, constantly producing hydrogen through water-rock reactions, then the term nature's hidden power plant isn't just poetic, it's accurate. The planet has been performing this chemistry long before we built electrolyzers. What's changing now is our ability to detect, measure, and harness it. With advances in geoscience, drilling technology, and gas analytics, we can finally access this energy source responsibly and efficiently. This doesn't mean electrolysis will disappear. On the contrary, both approaches may complement each other. Electrolyzers will remain vital in regions rich in renewable energy and water, while geologic hydrogen could thrive where the right rocks and minimal infrastructure exist. Together, they could form a diverse, resilient hydrogen ecosystem capable of serving multiple sectors, from heavy industry and transportation to grid balancing and chemical feedstocks. For policymakers, this convergence of science and sustainability opens new doors. White hydrogen exploration could stimulate rural economies, create high-tech jobs, and reduce dependence on fossil imports. It could also accelerate the timeline for achieving low-carbon energy targets by supplying clean hydrogen faster than large-scale electrolysis projects can be built. The challenge will be balancing excitement with responsibility, ensuring that this new industry develops under strict safety, environmental, and transparency standards. At the heart of it all is a remarkable truth. The Earth itself is an energy system. Beneath every continent, hydrogen bubbles through the rock, a byproduct of the planet's continuous transformation. For years it was overlooked, too diffuse, too mysterious, or simply misunderstood. But now, as humanity seeks cleaner, cheaper fuels, that forgotten chemistry is returning to the spotlight. What was once invisible could soon become indispensable, Imagine a future where hydrogen wells quietly power communities, industries, and entire regions without a single ton of CO2 released. A world where we don't extract fossil carbon from the Earth, but rather tap into the planet's natural hydrogen cycle to sustain civilization. It's not a dream, it's a direction. Scientists, entrepreneurs, and engineers are now racing to understand, regulate, and responsibly scale this newfound resource. And if history is any guide, revolutions often begin in the least expected places, like a forgotten well in Mali or a small seep in rural France. From those quiet beginnings, an entire global industry may emerge, one powered by the most abundant element in the universe, produced not in factories but by the Earth itself. At h2hub.reneenergy.com, we explore these frontiers in hydrogen innovation, combining science, economics, and real-world project insights. Whether you're a developer, consultant, or investor, our Hydrogen Project Starter Kit provides the tools, templates, and financial models you need to plan and execute your next project with confidence. Visit h2hub.reneenergy.com to join the future of hydrogen project development and discover how to move from research to revenue in the age of clean energy transformation.